So just checking whether recording is running. It's running. So welcome everyone to today's developer meeting. We have several topics today. One is more organizational topics, and the other is specific development topics. First of all, I changed things in GitHub, permissions, teams, rules, and so forth. And I want to know from you whether you have issues with GitHub or everything works as according to plan. Can anyone give me a hint on whether there are problems with GitHub at the moment?
Well, for me, it's perfect as it is.
All right.
The same.
Okay.
Always working, and that's great.
Okay. Rebecca, any issue with GitHub?
Working.
It's working. Okay, so
it's working.
I did it correctly, I hope. So whatever things that do not work correctly on GitHub, please tell me. Yeah? I'm quite new to this, and I'm learning what all these rules. Oh, there are so many rules. What they all mean. But just tell me whenever you have an issue. Please tell me. For second, we enhanced. Hey, there's Brandon. Hi, Brandon.
Hello, I just woke up. I'm making coffee.
Yeah, that's
Good
the
morning.
thing with the global community, with the global teams. People have it early in the morning in the US. We have afternoon, and people in Australia have late night already. So that's
No worries.
Maybe we can change this in the future for having, let's say, teams, European teams meet at that time and the American teams meet at that time. Maybe this helps. But for now, because we just have, let's say we're just 16 people. So when we get to the 100 people, then we should split this. So going back to Google Drive, the idea was to use the Google Drive as a storage for the machine learning material. I set it now to 200 gigabytes, now to 100 gigabytes at the moment, and I uploaded 85 gigabyte of Mike's material. I'm still having, I think, 50 gigabyte to upload, so we're gonna enhance the storage there. Before I do that, I want to make sure that this storage on Google Drive is working for all of you from your point of view.
Yeah,
Alex,
that's work.
so you can download, you can upload, you have access.
Yeah, I downloaded it and played with this data, so all was okay for me.
Yeah, okay. Yeah, there's Lionel. Lionel, you are working with this material. What do you say?
Yes, I haven't tried the download from Google Drive, but I don't see why it wouldn't work. But wait, let me just try, actually. I'm going to try away.
Yannick, this is also a topic for you. It's working for you?
Yeah, I haven't tried, but I'm just sent the Anfrage. What's that?
Request.
The word in
Yes.
English? Request is
You
exactly.
just sent the request for access. Okay.
Yeah.
Hold on a sec. I'm checking whether. Oh, you're not there yet. So the request goes via email, and I have to confirm that via email. So I can just give it in a second. So I'll do it in the evening.
Yeah.
So okay, my question is, shall we stay with the Google Drive if it's working for you, and we can stay there and just enhance the storage space so that we can in exchange via that platform material. Okay for you all?
Yeah, I think it's the best option. So we can all download it, maybe upload new data and experiment with this, in my opinion.
So for now, it's only the training material from Mike, which is only 120 gigabyte or so. It could become more in the future. So, Brad, what you say? Shall we go to the 2 terabytes?
Yeah. Au-dessus de l'armoire de Sophie.
Allow more. Okay. Okay. Perfect. And one last thing from the organizational stuff is I will just show you the team roadsters as is at the moment. Please check where you are, whether this is all right. So I rearranged just the team roster a little bit, so it's more easy to find. Okay, everyone has seen it. Okay, let's start with the user interface. Rebecca, I want to do this now every weekend, that we have several topics for several teams, and we want to start with the team leaders to give us just an idea what happened the last week so that everyone is on the same page again. In this case, Rebecca, would you like to start? You are muted. Here you are. You are muted. Yep.
How about now?
Perfect.
Okay. We recently set up a dev environment so that way everybody could get started working on it. I haven't been able to use that dev environment for a particular reason. You know, it just didn't work on my computer for whatever reason. So I went ahead and set up one separately for me in Django. And at this point in Django, I have a website up, and maybe some people might be able to start using it to start putting their own, you know, flourishes on that, the APIs that they're working on. I have one issue with the website I'm working on right now, with the user login. I had the user login working and then it stopped working. But I think I know what happened, so I'm gonna redo that tonight, and I can actually put it up on GitHub tonight. And you know, it's just it's a skeleton type of site, you know, for everybody to start designing and doing whatever they want with it.
So this is on a host, on a web host, and you create this service?
No, it's on it's, you know, on localhost. So you just download the code and work on it that way. But I do have a couple of Google APIs already on there working, because I wanted to just have something up for a sample so that other people could see it. So I do have a couple of Google APIs, like a Google Maps kind of thing, direction finder kind of thing. So people can look at that and sort of play off of that, you know, for their APIs also.
So this is a part of the dev setup, you say, and you put it on GitHub so that everyone can take it and create this dev setup according to yours.
The Docker environment is on GitHub, but I haven't put up the Django work that I've done, but I'll put up the Django work tonight.
Okay, perfect. Perfect.
Yeah, I know I'm perfect.
Oh yeah. So last time and this week was a lot of talking about WebRTC. Maybe you can give me an idea where you want to use WebRTC in, Brandon, or maybe you can.
Yeah. Can you hear me?
Yes.
So what WebRTC would allow us to do is, let's say you have set up the GUI on your home machine, and you are streaming data for your local like hardware. This would allow you to expose that so that, let's say you go visit a friend's house or you go to another country or something, you would have a URL where you could visit and watch the live stream. And the benefit of using WebRTC technology is the data is not streamed through our server, so there's no additional cost for it.
It's just a WebRTC service that runs on your local machine. How do you access it? Do you have to use a communication service outside of your place?
The by hosting the GUI on the web on like an internet server, this would give you access to a URL. Once you log in, you would get access to a URL that would begin the stream for your device.
Okay. But the streaming goes directly from P2P, so from your home directly to your endpoint, not via this service.
Correct.
All right. Yeah, okay. Understood. Any questions? Please, guys, this is a discussion today. It's not me asking questions and you giving answers, please. So whenever you have questions, please jump in.
One question I have for the GUI development is there some hardware, like basically a minimum set of hardware that I can purchase to have an example of what type of data is going to be piped into the GUI? Like, we're building this so that you can, stream data from your Sky 360, hardware, but it would be good for me to be able to know what I need to buy for the minimum data set that like the average stationeer is going to have.
So, okay, I'm bringing up the screen. Hold on. I have to share, I think, otherwise. Oh, didn't I share before? No, I didn't share. Oh, my dear. So I share this screen now. It's complicated. Do you see my screen?
Nope.
Yeah.
Ah, yeah. Duh.
Okay. So in the system, yeah. So everyone sees the schematic.
Yeah.
Okay.
I see it.
Okay. So what you see, this is the schematic of all the components within the station. And on the top right, you see the GUI service, the GUI server. This, what I termed with Pi GUI, meaning a Raspberry Pi, but you can decide what you think is the best platform, the best board for using this. The idea is that the user interface service shall run on that board and pick up all the data from the NAS, for example, direct communication with the master control program, exchanging controls for PTTS, and so forth. So whatever you decide what your hardware, your Pi GUI is the one where your web service runs on, or any kind of service that you need for your front end, for your user interface. But was this your question, Brandon? Hello? Oh dear.
Can you hear me?
Yeah?
Yeah.
Okay.
Maybe. So like the live view, if I understand correctly, does that come from the BTS? Like the red line that links the BTS to the GUI server from the PTZ cam. What data is that transferring?
Good point. It's a live view.
I want a question.
Yeah, Kristen is not here today, but it's a live view.
Live view, yeah.
It's a live view. So
What format is that data in?
that's a good question.
And it's maybe if I just need to sync up with Christian to get these answers.
Yeah, you could get more details from him. But what I just know is that this is a live view data stream.
Okay, one other question.
Yeah.
The archive management, that red line, is that representing the GUI accessing archived video data?
Yes.
And what format are those videos in?
Yeah, we are discussing still MKV or MP4 video containers.
Okay.
Does this answer your question?
Yeah, that answered my question.
Okay.
Why we compressing the data? We losing then quality, right?
A video has to be compressed in order to be stored. When it's streamed, then you get it bit by bit, I'd say. More or less also compressed, hardware compressed, decompressed. There's always a compression involved with video material. Otherwise, you would never reach 15 or 30 frames per second.
Yeah, but we losing then quality. Every time you compress.
Matroshka, the MKV is very high quality video material. So we tested we compared MP4 material with MKV material a year ago, especially with 12 megapixel material. And MP4 is really very much worse. So especially when you go into higher resolution videos, then MP4 is actually not so good. It has pros when you have, let's say, an HD video, but our resolutions are much higher. So that's why a Matroshka MKV file is, from my point of view, but it's open to discussion. From my point of view, I'd say MKV.
Okay, so we compress video for, excuse me.
Go ahead, Alex.
Okay,
sorry.
We compress video for better optimization, yeah? As far as I understood.
Once again,
I mean, speed.
I didn't get it correctly. Can you repeat?
Okay, as I understood, we compress video for better optimization in our site or maybe storage, yes? I mean, for speed, for download quality, and that is, or no? If no, forget about it.
First of all, we have to compress any video. It's not, it's a format, and the compression is in the format. It's if you take an MP4 file, it's an H.264 or 5 compression. So,
what is the format of the source file?
So the question is, which source file do you mean at the moment?
Like if we select MKV, where does the MKV come from?
Now, actually, the MKV in the future, the MKV would not come from anything. The MKV will be the storing result. Normally, the tracking software running on the Jetson has direct access to the device, the camera device. So there's no file handling here at that point.
Yeah.
Okay. In your case, because you're developing this, you can use your camera, you can use any kind of a webcam fulfilling the same role. Because we do not have the final camera we are going to use for, let's say, the all sky cam application. We are still using the Dahua 12 megapixel Ethernet cameras, which we want to get rid of as soon as possible. And I'm scouting for 1-inch sports sensor cameras, which is not very easy to get at the moment because of the pandemic, the worldwide procurement issues.
Yeah.
For now, Christian implemented the INDI interface, and this can take any kind of a camera. You can take a USB camera, network camera, the Dahua can work with it. You can take a MIPI camera, what have you. You just put it on, and that's your stream. That's the material where the machine learning, all this motion detection is processed on. And when you do a live view, I'm not quite sure which format. This has to be discussed with Christian. But if it is then stored on the NAS, or the local NAS, then it will certainly be an MKV file. So in an event view, if you go back to a historic view, for let's say from yesterday, you would pick up an MKV file.
So one thing to consider is maybe which type of compression that is. So I'm just reading there are lossless and lossy compression formats, basically. So when I read MP4, for example, is a so-called lossy compression, which means that every time you save it, some parts of the data are discarded, and lost. So I think it would be really good to have a lossless compression.
Yeah, it was a retested MKV with H.264 and 265 compression. The only issue was that 265 was not playable on Firefox, something like this. But this can be changed in the meantime. So this is information from last year. Well, someone has to test it. Create an MKV on H.264 or H.265 and look whether all browsers can take.
And does someone have a? Oh, I can find it. I just need an example of both 264 and 265. I'll find it online.
Let's see if I can make it. Make one.
Brad, you have 265s.
Do I?
Yeah. If you run the old Skyhawk software, you have 265s.
I was running it straight off my camera, so.
Ah, okay. This is the Dahua stuff. Then it's 264.
Okay. I didn't know if I had the option to record both. I could make an example of both, but I can't.
Can you? No. Oh, it's fixed there. Yeah.
I think a good idea too would be where you have the lossless file, but you have an option to save it as an MP4, maybe for more unimportant videos.
Mm-hmm. Yeah, why not? Yeah, absolutely. For posting on social media, for example, where MKV is not supported, kind of, yeah. Mm-hmm. But I think staying with MKV files in our NAS and on the local storage, I think makes much more sense than using MP4s. So Brandon, your question is, I can give you the answer for the local stored file for the historic events, but for the live view, you better ask Christian.
Okay.
Christian coming? He's moving.
He's excused today because he's moving from one part.
Okay.
From one.
Oh no, I can actually make a comparison. I can set it to 264 or 265.
Really? Okay.
Yeah, there's a drop down menu here I just found.
2 videos and put them on the drive so that Brandon can pull them?
Yeah, I have to figure out how to do this without a ladder involved. But yes, I'll figure it out.
I have a question.
Go ahead, Bojan.
Okay, so we're using fisheye videos all the time.
Yeah.
I mean, we're recording nonstop.
Yeah.
Right?
Yeah.
Why we saving that? Not, I mean, in the future, because you have PTZ set. And you actually recording in a close range, zoom it, whatever. We don't need to store, or we need to store the videos.
So in a normal
From fisheye camera.
Yeah, I got your question. So normally we do not store. If there is no event, we do not store. Why should we? So
Okay,
only in the
okay.
case that there is a signal that is detected by the the kinetics classifier or the neural network identification, then not only the PT set is activated, but also the fisheye material will be stored because we need this
Okay. This
for
part.
later
This part.
analysis.
Okay.
And still,
Okay.
the fisheye, the software on the fisheye is running 24/7. It's non-interrupted. It's running always. The PT set is only
Yeah.
running on events. But at the time of events, the two views are also important for triangulation at the same time. But yeah.
Okay. Got it.
Also, so means Brandon, you can work from there. If you can take those videos from the drive already. These are MKV files.
Yep, I'm looking.
Yeah, and just ask Christian about the streaming point. And maybe you have to come up with a streaming idea. I don't
Yeah.
know. I don't think that this is already discussed with Christian. I think it is still one of the open points. But you will see. Just point to him. All right. So, any other questions around this, the user interface and video material? Shall we skip over to the next topic? Okay.
I have a short question related to the weather map we talked about, and I'm currently experimenting with a package that is called IPI Leaflet in Jupyter Lab, and I'm not sure if that is a good framework basically for the GUI, because I have nothing to do with web development in my day job, so I'm not very experienced in that. It's the package is called IPI Leaflet, and it works in Jupyter Lab. Does anyone know Jupyter Lab?
No.
Okay.
Jupyter Notebook.
Jupyter Notebook, and I'm not quite sure. So it's basically Python.
Yeah.
But I'm not quite sure if it's like compatible with the, for example, this Django framework, and if I should go down this route, or if I should look for other things to put basically to put data on a map.
I'll need to research that. I just now found this package.
Yeah, so you can export this map as an HTML file if you want, but I just started with that, and I'm not sure if that is what we want. So
can someone share a screen so that we all can see?
Yeah. Just a second. Let me see. So, do you see my screen?
Yeah.
Coming.
I mean,
Yeah.
no.
Okay, so that is what I got today. So I have a little map, but I just started. So just as an example, basically, and
What is on the right side?
that is just an example for like a temperature curve or whatever. Maybe we don't need that, but I'm just, because last time we were talking about putting data on a map, and it could also include like airplane positions and maybe satellite positions or something like that. And that is using a package called IPI Leaflet. And Leaflet is basically a package that is a JavaScript package but I'm also not quite experienced in JavaScript. So I thought, and we said we want to work in Python. So I discovered this package called IPI leaflet, and that's using this leaflet package for Python. But in this Jupyter notebook framework, let's say, and I can export. In principle, I think I can export this as an HTML file. And then I'm wondering, is that, because I'm not experienced in web development, so I'm just wondering, is that a good path that I should look into more, or is that a waste of time? Basically, that's what I try to figure out.
I think if this is running in Jupyter, then it would cause us to have to ensure that the server can first run Jupyter and then run this this plugin. And I think there's no other use case that I know of where we would need Jupyter.
Yeah.
Long story short, there's a lot of free open source weather APIs that we can use. I think that would kind of circumvent the necessity of this plugin.
Yeah,
It does look cool, though.
Yeah, this is actually using the Open Weather Map API.
Yeah, so we can access that directly without needing to run Jupyter Notebook.
Yeah, that's yeah. I guess so too. So
open OWM weather map.
Open weather map.
If you want to, you could always send us a copy of what you have there on the screen, and maybe we can see if we can put that into the Django website.
Mm-hmm.
I can't see it too well. It's very small on my cell phone.
Yeah.
But if there's enough code there, maybe it's just a matter of just maybe changing a few little things and it'll work. But without seeing it, I can't say.
Name for my dog is Django, and every time somebody says Django,
Okay.
Doesn't matter.
So, Yannick, this is using an API from a service from an organization, right?
Yeah, that's using the Open Weather Map API.
Weather Map API, okay.
Good weather API.
So the Open Weather API is an API that can be called from any kind. This doesn't necessarily have to be a Jupyter. It can be.
Yeah, that's true.
Django as well. Okay.
I think so. I just have no experience with Django, so yeah.
Okay, maybe you can connect with Rebecca and check this out. What works?
Yep. Okay.
All right. But this is actually true for all external sources. So all external sources you have, you should check with Rebecca for accessibility.
Okay.
All right. Any other topics about the user interface? Anyone who wants to say something, contribute something, discuss something? Any topics? Not for now? All right. Yeah, so okay, let's go over to the OSCAICAM team, and especially this whole recognition, detection, identification, classification thingy. I will share my screen now because I want to show you someone shared screen. Can someone stop sharing? Otherwise I cannot share. Why can't I? Now I can. Okay, sorry. Now I can. And I'll share this one. No, this one. Okay. You see my screen?
Yeah.
Okay. I'm So this is basically the idea of the all SkyCam software, that the thing that is in orange. Okay, we have a source, which is a camera, which is hooked on INDI, so it gets available for, yeah, the next step is, let's say, motion detection. But you can also use an MKV file that's from the existing material and open that file and do the motion detection part. So our idea is, and we talked about this last week already, is to have this 3-step process. The first, it's a bad thing that Mike is not here today, but what shall we do? So the thing is, the first, oh God, go away. So the first thing is the motion detection. And after discussing with Mike and with Christian and others, we come to the point that it doesn't make sense to have an AI or a neural network to check on the big aperture of the material, to say, let's say on the 20 megapixel material, to detect and identify what's running there, what's going on there. So we think that classic motion detection is the first step we have to do. Because it's robust, it's existing, algorithms are there, they are tested, and Mike did test, and I think that the outcomes of Mike's material is quite good, because he could also detect very small objects that far away with only a couple of, let's say, 4 or 5 pixel representation. He could even detect them and even filter out background noise, such as raindrops or moving, chasing clouds. He still has issues with trees. Do everyone understand me? Hello, are you there?
Yeah.
Yeah, okay.
Yep.
Yeah.
I'm not talking to myself
Fine.
right now, okay?
No, we're there.
Okay.
You talking English, you're not talking German, so
No, the
that's
thing is
okay.
that my streams, the RTC stream
Yeah.
is interrupted sometimes, and then I'm talking and I'm not realizing that you guys are on a different page.
No.
Okay.
I hear
All
you.
is okay.
I hear you all the time.
Okay. So
I have good reception too.
thank you, Rebecca. So motion detection is, from our point of view, the basic thing we have to do first, just to see that there's an event going on, and there's nothing to do with clouds, with trees, leaves, and other stuff. And then the next step is, and this was introduced by Lionel last week, is to create a kind of a kinematics classification. And because Lionel, you are here today, maybe you can again lay out your idea about it, because some people were not there last time. Lionel, are you here?
So, you hear me? Yeah. So it's just to highlight some characteristics of a movement. So based on its direction, it's the size of the object and the speed of the object. I'm really sorry. I had a really busy week at work, so I did not do any progress. Just this morning, I was working on getting that speed data, and once we have those couple of dimensions, so it's just 3 dimensions at the moment, then we can do some basic classification and the part that's I think is challenging, and the prediction of where the next green box is going to appear.
Yeah.
So by means of prediction. So I think that's challenging.
Yeah, absolutely.
And yeah, so that's it's like a multi-layer layered problem of so it's several layers of algorithm stacked on top of one another in order to achieve the final classification and the slew of the scope of the telescope.
Yeah.
So it's nice that that we have this schema. It's cool that you did that, Richard.
So the idea is, because you only see cropped parts of the image, the dashed is just because it's just a little part. I couldn't put all the whole view into it, otherwise the event would be too small to see. So please consider the dashed lines around these squares as just a cropped part from the image, from the frame.
It's a 12 megabyte image, so it's 4,000 by 3,000 pixels.
Yeah. In that case, but will become 20 megapixels in the future. But yes, it's a big real estate of the frame, and the event itself is a very tiny spot.
Yeah, that's the beauty of what we already have, is that motion detection layer. So that first layer, I think it's really neat. It's perfect.
It's incredible work that Mike did.
Yeah,
and he didn't even pull all strings he has. So there's still room to move for him. So what I want to say is the classification also runs on the same material, on the same size, but more in a sense that you already get the bounding boxes, you get the vectors already from frame to frame.
Yes.
So you don't have to work on an image-wise, you more work on a logic-wise, because you already have the bounding boxes. Because of those vectors, you can derive speed, distance, time, whatever you can derive from these bounding boxes. You can even vector ahead and say, okay, where will this object be in the next second, for example, which is very important because it allows us to, for example, if an event appears close to the edge of the horizon and it's only there for 2 seconds, and you in your classification also can, because of vectoring ahead, see that it will hit the boundary, the horizon, within the next 2 seconds. The question will be if this event will be skipped at all, because we will never be able to do a neural network identification, a stable one, plus slowing the PD set towards it. So what I want to say is this vector ahead in your kinematics classification gives us a very early information how long probably an event will be alive in the view.
Well, that's a fact that if something is moving towards the outside of the frame, so outside of the field of view, then it could be classified, but it's not going to be documented by the scope, because you need a couple of green frames with a green box to start the classification. So that's
right.
a fact.
But consider this as, in this case, we only see one event, but normally you have multiple events.
Yeah, that's true. That's true. There could be multiple tracks. That's what it's called in the motion detection. It's the tracks identified by a number. Here it's track 19. But there could be multiple tracks on the same at the same moment.
Exactly.
And
can I ask something?
Yeah, go ahead.
I was thinking about infrared detection.
What has this to do with this?
Oh, instead using fish eye, we can does exist infrared fish eye camera, right?
Infrared sensors, yes. Bojan, infrared sensor is always a normal sensor with enhanced spectrum into the infrared.
No, I know I'm talking about why infrared can be another spectrum. Why we not have another scanning another spectrum?
You mean
Clear about
several
it? No.
sensors with several spectra?
Exactly.
Yeah, we can
Let's
do this in the
let's
future.
say
This is certainly
no.
possible in the future, but for now we
Uh,
stay
uh,
with a
uh,
single
in
camera.
a sense, these events, a UAP or UFO or whatever event can happen in another sensor spectrum, not in our eyes spectrum. That's what I'm talking about.
Isn't the Dahua cam already equipped with a nice
Yeah.
IR infrared layer
So
that
the
sort
camera.
of highlights or betters the image? How does it work?
So in principle, we are using mostly we're going to use IMX Sony Starvis IMX sensors. They are mostly I say because it's not true for everyone. They have spectrum ranging into the infrared, but not far. Not into the mid infrared, only to the near infrared.
Near.
Okay. If you go into the far infrared and even to the thermal infrared, then things become very expensive and low resolution. So one goes not with the other. So you can't have both. A FLIR, for example, you can buy FLIR for $5,000 and you still not even get HD quality. So yes, Bojan, you're right. In the future, we will have several sensors running with the same software on those sensors, on the sensor material. But for now, we stay with only one fisheye camera for the beginning, because when this is done and we have the software running with one fisheye camera, it does not make any difference if we change the sensor. Just take a UV sensor. Just take, for example, a FLIR sensor. The software will probably stay the same.
Yeah, but you remember we was talking about. I was in Kansas City downtown airport. The Brad knows about it, and I saw the triangle object up high up to the sky, and then I took picture with my phone. Guess what? On a picture, no object at all.
How do you explain that?
I don't know.
How big was it when you stretch out your hand? How big was it? Thick like a thumb or smaller?
No, this is like a high up in the sky, triangle, like a.
When you put your hands out, stretch your hand out, how big was it? Can you tell me in millimeters?
In terms of your hand.
Oh no, this is small ones. I mean,
Yeah,
I
so
can.
Let's say
if you hold a nickel, like if you hold a coin outside, if you hold a coin like this, how big was the object compared to the coin in your perspective?
Like a point in the middle.
Yeah, see?
Point in a small point in the middle of the coin. Yeah, so
Yeah,
then it's not that big. It's
I
not that
saw.
big.
Hey,
So
no, but I saw triangle.
Yes, you with your naked eye can do that. A smartphone camera has an
This is my
aperture
problem now.
that is much smaller than your eyeball. That's why you cannot resolve this on your smartphone, although you see it with your eyes.
This is my problem, Richard. This is my problem. So, how can we do this with the fisheye camera? I mean,
because the fisheye camera we are using has a much bigger aperture. Your eye has an aperture of 5 millimeters. The smartphone camera has an aperture of 1.5 millimeter. The aperture we are using for our fisheye cam will have 30 millimeters. Okay? And
my
yes,
point
we
is,
will see. Your point is irrelevant because we will see the
no,
ISS.
it is in a sense. Can we scan some other spectrum?
Yes, we were at that point already. Yes, we can
So,
use other
so
sensors
we
in the
don't
future.
care about our eyes or whatever camera stuff. It's any kind of spectrum. So we can sense. I'm not talking about movement. I'm talking about, for example, this UAP, UFO has different reflection than bird, than airplane, than, you know what I'm saying?
Yes, of course. We start with one sensor, with one fisheye sensor. This sensor will be a Sony Starvis IMX, maybe a 541, this is my preferred choice, or a 335, whatever. This has a range of 300 to 1100 nanometers, meaning it ranges into the near infrared. Okay? Of course, we can have other sensors in the future and just plug them on. The enclosure already has place for two fisheye sensors. So we can enhance the system with multiple fisheye sensors in the future. And but this is not a discussion for now, Bojan, because now we are talking about software. And
Okay, I'm
the
sorry,
software
I'm
that
just
we solve here will be applicable to all other sensors in the future. Okay?
okay. I'm just asking. You
And
know, you said
this sensor that we're going to use right now, this year, I hope I'll find it soon. This sensor with the optics, with the fisheye optics, is way better than your human eye. Okay? Your
okay.
smartphone is way worse than your human eye. Okay? The smartphone is rubbish compared to your eyeballs. And
Do
your eye.
not call my cell phone rubbish, please.
Okay. But you get the point, okay? So,
Yeah,
Lionel,
yeah, yeah. Okay.
I roll back to you
Sure.
and the kinematics classification,
Yeah.
where I want to point out the importance of vectoring ahead, because we were at the point where we have multiple events at the same time in one frame, multiple events. As you said, number 19, for example.
Yeah.
It is um, a question of resources, because if we do the next step, let's say cropping out that event, which you see here, the next three images are, let's say, 128 by 128 pixel images. So this is the material that should be the neural network should be trained on, and this is the material that the neural network shall detect whatever is inside this material, meaning we only have 128 pixel frame wise, but having, let's say, 10 events at the same time, meaning we have 10 times those 128 pixels frames per frame, per every single frame, meaning when your classification is capable of vectoring ahead, telling the lifetime, the expected lifetime of an event, then this is crucial for whether we take and extract the 128 pixel aperture or not. You know what I mean? This heading over to the next, this one, this arrow here.
Yeah.
Your
Yes.
classification.
Okay. So you mean that green box is a green box should resolve to a 128 times
Yes.
128 pixel.
Yes.
Okay.
What
Example.
do you mean by green box?
The green box in the
This little green box
middle
here.
frame.
Okay. Uh-huh.
This tiny little
That's,
thing.
yeah. Well, I think that if you have once I manage to extract the speed information, I think we can make some safe prediction on the position of the next green box. Is that the question?
Yes, yes, in a way, but also the expected lifetime until the event falls out of view. Because, for example, the last event 19 on the top right in the script.
Yeah.
If this is close to the edge, and we know it will only last for the next 3 frames, so it doesn't really make sense for us to go through the neural network identification and then even go to the PT set, because 3 frames and it's over.
Yeah.
You get my point? So that's why I think
Yeah,
your
that's
classification plus the vector ahead that you can do, because you have the vectors to these bounding boxes, and because you know the path, you can estimate the flying path. Maybe you can imply a B-spline curve on it, kind of. You can estimate the time of life for this event until it reaches the edge of the field of view. And then, because of this, when we have this information, we can say, okay, this lifetime is still enough, so we can do the neural network thing and then head over to the PT set. But if the lifetime is not large enough, because it's only estimated from your classification only for the next 3, 5, or even 10 frames, then we can skip this event, because anyways we have 10 parallel events running. So the more events we can filter away because they are already classified as a bird from your side or classified as a plane from your side, let's say with a high prediction, with a high probability. But also to say the lifespan of this event is not very much, so we can even skip this and not going over to the neural network.
Richard, wouldn't that mean that we could or we should have a minimum time an event will appear in the future? So this, you mean this is the first filter to filter out traffic or events we couldn't further go into? Yeah. Couldn't we see the PTZ as the time giver? Because we could calculate our time we need to move the PT set at the maximum length, and then sort everything else. What will need less time?
We have to recalculate this.
Yeah.
First of all, the event is never there where the PT set points to.
Yes.
So it takes
That's
time.
the reason.
It takes time to slew the PT set to the particular point in the future.
How much? How long is that the slew time? So if
we have about 20 degrees per second.
Okay, so it depends on the distance, the angular distance has to travel. 20 degrees per second. So the full 180 degrees. 9 seconds.
Yeah, about 8 seconds actually. Yeah. About,
Will we move the PTZ to a kind of standard position every time we have no events to discover?
Yes,
so
absolutely.
And this will be, I guess, upright to the top.
Yes.
Exactly.
Yeah.
So we have 90 degrees, 20 degrees a second. So everything is what's less than one second could be filtered out.
Yeah, you can't say this as a rule, because your because of the last event that the BT set was recording, it could be by incident that at that point another event arises, and so it is at the
And
perfect
it's nearby.
and it's
Yeah.
nearby. You can't make a rule out of that, I think.
Yeah.
We have to
Okay.
calculate it on demand.
Yeah. Okay, got it.
And more important, and this is my point towards Paul. And Paul, are you there today? No, Paul is not here. Did I? No, Paul is not here today.
No.
Sorry, Paul.
And,
If you hear
and
this,
Mike is not there.
yeah, Paul, if you hear this, I point this to you. We have to how I say is we have to take the standpoint that we have to deal with several events at the same time, because there's always a bird involved, there's always a plane involved, there's always a drone involved, and the UAP. So because we do not know in the first frame what is what, we have to find out. So we have to check everything, meaning that the kinematics classification is that step that tells us with a certain probability it falls into a bird range, it falls into a plane range. By having this classification, we can already rule out certain events. Let's say we are not interested in birds, we're not interested in planes, for example, and then there are only the leftovers, the unknowns. Maybe there are 2 events at leftovers, and the neural network has to work on those 2 events. So the less events, the better the performance will be. That's why I see the kinematics classification as a reduction of events. The motion detection is an increase of events, because Mike is finding all kind of events in the sky, which is not background. But the kinematics, Lionel, your work is to filter out those events from, first to classify them in order to be able to filter them out. And also the kinematics itself, the time to life, the time until it hits the edge of the field of view, for example, is a very crucial one, because if the time is too small, it doesn't make sense for the neural network. We have to find out where these values are. But I'm not talking is only brabbling. I'm talking about an idea, yeah?
But
we have to find this threshold.
But one thing that maybe some element of answer is that when you classify data based on multiple dimensions, the classifier sees a data point and he knows that on this particular dimension, let's say on the dimension speed, it could be definitely a plane, because it has the speed of a plane. But there's always a level of uncertainty where it could still be a bird. So this is like a 5%. In terms of speed, it will be let's say 95% a plane and 5% could be a bird. Could still in the realm of possibilities. So I think that in time we're going to learn, like as humans, not as machines. I think in time we're going to learn what is the defining factor for something interesting.
Exactly. That's why it's so important that you work on the training material. Because
I'm sorry I didn't have any time this week. That sucks.
No
but
issue. No,
like that.
Don't
like
be sorry.
That, you know,
this
sometimes work
is true for everyone who contributes here. We are contributing our free time, so no one has to excuse him, or everything you contribute is thanks. Everyone thanks you that you contributed this. You do not have to excuse to everyone for not doing something. Okay.
No, not like that. But like you wish that it went forward and that you reach MVP stage pretty soon. That's what I wish, at least.
Yeah,
Wish
I
that.
wish too. I wish to have 10 Lionels. I only have
Hey,
one.
hey, Lionel. Hey, Lionel.
Yeah.
You must put in a factor. Then the aliens is smart, so they can learn how bird or helicopter can move, so they get smarter. You know what I'm saying?
I heard about that.
Yeah. So how can we detect them? This is problem.
I know, I did read about that. That's what people say, that they well, I don't know. Let's not. I'm
Yeah,
not.
why not?
Yeah, I'm not, I don't want to speculate too much, but
Let's discuss this for a couple of minutes. I have to go to the toilet for short, for 2 minutes. Give me just a 2-minute break, please. You
Come
can go
on,
on with this
stay here.
discussion.
Come on, stay here. This is. Oh my goodness, so many factors.
And Lionel, I have a question. Could it be interesting to include also directional changes, like per second, for example?
yeah.
Because, for
Actually,
example,
it should not be one vector. It should be a series of vectors.
something like that. For example, I think of insects. They change their direction very often.
Yeah,
And
that's a huge factor, like the change of direction. But I had trouble just representing that myself, like in terms of data. Like how would I shape a variable to hold a series of vectors in terms of data modeling?
you
But
would
if
need,
you can think of something that's, I think that's the
you
way
would
to
need
go.
the angle. The angle. That's the same like this azimuth zenith type of thing.
It's just that you have to wrap it into something bigger. So you do the azimuth and speed and stuff thing, and then make that part of a bigger data structure.
Yeah. You could, for example, like put for every frame, calculate the angle between two frames, let's say, for the object, and the distance of the box, right? And then you can store that in a list or something like that, and just look at the last 10 frames or whatever, and just check how many times did the angle change by larger than, I don't know, 5 degrees or something like that. So, and then there should be a difference between how that looks like for insects compared to birds, compared to planes, I think, because insects, for example, change their direction a lot, right?
Yeah.
And birds sort of do that, but not so often. And planes don't tend to do that, right?
These UFO objects looks like they don't have a mass.
Right.
And then can change the direction, whatever. Like an insect.
That could be actually, that could be, maybe they move like insects. Like actually, that could be the differentiating factor, is that they turn on a dime.
Yeah.
Well, that they do, and we actually have video of that.
Yeah.
The insects has little mass, so they can go left, right, up, down, whatever. They have incredible speed, though, and so UFOs, like insects, they can change any direction at any speed, whatever, because no gravity, right?
What else could be interesting, Lionel, is shape changing. So a plane doesn't change shape. Otherwise, it turns kind of. But a bird flaps. So yeah, either you have the full body or the spread wings. The full body, the spread wings, kind of. I once saw
Yeah, you're right.
I once saw a bird flying over Vienna. I saw it from the very distance with my binoculars. It was a black bird, and I would say it was of the size of a stork, so actually a huge bird. It was black towards the sky.
What is stork?
But the
What
thing
is stork?
a bird. But the thing is, I watched it flying over Vienna. So the whole city, I saw it crossing the whole hemisphere without any flap. But I could see with my binoculars that it is a bird because you saw the hanging feet. And I thought to myself, is there a bird that can fly so far without a flap? And there was not much wind speed, so there was not much.
Oh, well, actually, most birds don't flap their wings. All the eagles, they never flap a wing. You know, they fly using thermals.
Yeah, but they spiral up to do so. But they would not do that on a straight line across
Yeah,
one
then
long
it
streak. Let's
would be
say 5
they would be
kilometers.
gliding.
So the bottom line is not a bird, right?
That's my. I can't point my finger on it. I can just say from my feeling, it looks like a bird, but it doesn't behave like a bird. I wanted just to contribute to this discussion right now.
So I'm gonna post a link to a YouTube video that's relevant to this. This is a SkyHub video from March that we reference a lot. It shows a type of object that we need to be very careful not to lose. It like what Boyan's talking about. It looks like a plane at night. It exhibits plane-like characteristics, and then, lo and behold, it does incredible maneuvers, and then exits stage left at an amazing speed.
Did you post it right now?
Yeah, in the machine learning channel.
Oh, okay.
So if you fast forward a little bit, I mean, like a couple of minutes, but it stops. It's blinking, but it stops midair, which a plane would not do. So if you looked at any of our standard plane videos at night, this looks just like it's a blinking light. So if the machine learning algorithm learns to toss out all the blinking lights, we miss it.
Yeah.
It changes.
What's the huge fireball?
Fireball. There's a helicopter that flies through.
Probably.
Okay.
Or with a searchlight on, kind of. But this
they keep
was not the important one, the tiny one.
Yeah, it's that blinker right there in the center that you got to keep your eye on.
Stopped.
You see the blinking light right in the middle of the view.
There's this the schematic, the sketch from the movement. Maybe you can post that too, so that they know where to look to. This is a good point, Brett.
But the point is, if the machine learning algorithm was kicking this out because it thought it was a plane, its behavior changes midway through the scene, and then it becomes And this is like the low-hanging fruit. Nothing does this. Like, we need to catch this kind of thing. We have to be sure we're not tossing out this, because this is excellent material.
And how sure are you that this was not tampered with?
Tampered with?
You
mean the material, the video?
Yeah, that somebody using After Effects made that video.
This is the raw material. I mean, I have the raw material, and I cropped out from time to time just the piece.
So you still have the raw material. You still have the raw file for this.
Mm-hmm.
But this is only
then you're
cropped
sure.
time-wise. This is only from to taken out.
Wow, that is one crazy
But this
video.
it's a very good point from Brad that whatever we find, it can change its behavior. So whenever you have a classification as a bird, and suddenly it behaves like a plane, then this is an alert that should raise an alert flag.
Yeah, this is my point. These motherfuckers is very smart. If they don't want us to see them, they can do anything they want, right?
Yeah, I mean, everything about that, I would have said that was a plane until it did what it did. When it stopped completely, it looked, like blinking navigation lights on an aircraft. So yeah, that's a very, very good case to bring up.
It could still
You
be
know
a
what?
helicopter.
We are
A
dealing.
helicopter would not turn on a dime on 90 degrees angle without
Right,
without decreasing
Mhm.
velocity. It's one straight velocity.
Yeah, so
Mhm.
the non-ballistic objects are the ones that nothing does that. I mean, yeah, an insect and a bird, they can pull high Gs, but they're small and they'll be very close to the lens of the camera. That was relatively high up there, so in order for it to be as big as it is, or as many pixels as it is, it had to be a fairly sizable object. So, what does that?
My point is we're dealing with smart, very, very smart beings. So in order to detect these beings, we need to be step ahead.
Whether they're smart or not, we just have to have an anomaly detection system that will pick up weird things like this that kind of fall in between the lines of it looks like something, but it's really not something. That's not what we think it is.
Looks
Rather,
like A but behaves like B. Or
exactly.
starts like
anomaly
looking
detection.
starts like looking and behaving like A, and suddenly over time suddenly it turns out to be something different, so changing shape or changing speed, changing behavior, kind of.
This is my problem. We need to, like I said, we need to be step ahead. How can we do that with very intelligent beings?
We just have to watch, we just have to look the material and see. But that's my point to Lionel. If his classification points out it is A, but over time it turns out to be B, that should raise a flag. Change in behavior, change in shape, in size, in speed, whatever.
My point is we need to completely change our point of view.
Why?
Because we are humans. You're looking like a human. You try to detect something, then okay, strange, but we need to change the point of how can we detect something straight. We completely need to change our mind.
Yeah. Yes.
I'm not, I'm not, this is not philosophy. This is just if these, the beings, very intelligent beings, they don't want to be, if they don't want to be seen, right? We need to change tactics. Hey, this is it is not a war, but war tactics. Hey, we gonna detect you, but I like a organization or whatever. We need to change tactics. Do you know? I'm not cheating about it. I mean, I'm just.
I know what you mean. It's about countermeasures and countermeasures. And yes, you're right. When we over time recognize that there's a behavior change, then we have to change our model.
We need to change our perspective, our way to see these things, because they're intelligent. But also, we are humans, we are intelligent too. So please understand that we are, our civilization is intelligent enough to fight these things. You can.
We're not going to fight
No,
them. We're
hold on. Let me finish. So you coming over in our skies, messing around, do whatever you want to do. I'm sorry. This is not a war, but hey, let's move forward. You know what I'm saying? I mean,
yeah.
I just want to add.
Understand what is my point?
Yeah, we have to be adaptive.
Maybe I can add something about machine learning. Is that anomaly detection? It's something that's well handled by machine learning using what they call auto encoder.
Mm-hmm.
So I think that I think that it will work to detect the anomalies like that Texas UAP. I think that would have been caught by the system we're building.
Okay.
But it's cool that it's in the training material because like you say, Brad, that's the one thing we don't want to miss.
It's actually not in the training material, but we have to put it there.
No, it is. It is in the training. The Texas UAP, I think it's in the Git repo. Is it not?
So I posted. I have another unknown that I caught here a couple of days ago. It doesn't do anything that spectacular.
UAP Texas Skyhub.
Oh, okay. So it is up there.
Let me see if it's the same. Yes, I see that blinking stuff. So it's in the Git repo. It's called UAP Texas Skyhub.mp4.
Where did you find it? On GitHub?
In GitHub, it's in the vids folder of the simple tracker repo.
Aha, okay. Mike must have put it there. Okay.
It's called UAP Texas.
Mm-hmm.
So the only other unknown that we have is if you downloaded my videos, I have the unknown folder. It doesn't do anything like that, but it's not. I can't identify it as a plane. It might be a plane, but it doesn't blink, and it's high up there, and it kind of leaves a contrail. So
you mean the long, quick streak over your sky? The very first video
those
in your
tricks.
Okay.
Those tricks with the boat. This video
This
is insane.
This is in the unknown.
I know it's something else, but it's insane. If that's an artifact, if that's a video artifact.
Are you talking about the streaks?
Yeah, the streaks with the sunken boat. Somebody posted that in the DMZ. That's
you mean
an
something
insane
different.
video.
So what you mean, Lionel, is a video from an
and
astronomer.
then Brad said that he had the same artifact.
But this is a video from an astronomer who set a camera on the beach where there's a stranded boat, and then there are streaks on the right, very right, red streaks.
Yeah, I send you that. This is a fantastic.
Yeah, but
this is fantastic.
Yes, it looks fantastic. But from the whole concept of, first of all, he uses very long exposures because he wanted to capture the night sky.
You can see the movement.
Of course, you can see a movement of insects as well, but you cannot. When you take a long exposures on insects, you cannot.
This is not an insect.
Who says?
Come on now.
Says who?
Well, you
insects.
You make me speechless.
No, I mean. First of all, my issue is this because they're very long exposures, and that's why we cannot learn anything from this video, from this particular video.
We can hold on. We can learn trajectory, right?
Yeah. Okay. Looks like insects.
We can. We can learn. Okay, we can with PDZ future set. We can hold up the object, but also with this kind of stuff, we can learn how these objects The bottom line, I mean, I'm not going to say again, the bottom line, we are dealing with very, very, very intelligent beings. And we need, in order to detect them, we need to be one step ahead. The question is,
How?
Oh,
Yeah.
are we intelligent enough?
Yeah.
I know I'm not.
We will see. I mean,
But you know what?
But Bojan, it
I
could
like
even be the other way
this
around. It
setup.
could even be that they don't care. They just don't care.
I do care.
Yet
I do
but
care.
you were talking about the others, and they are
Let's
intelligent, and they
circle
could
back
mimic
and
something that we do not
You know,
understand. But it could also be that they don't care. So it's both
no,
is open.
I do care. I do care because I have a kid. All
Yes,
of
this
you
is
have a
true.
kid. And I need for my kid to be safe and good life, have a good life in this priceless earth. And somebody coming over, to do whatever you want to do without detection. So this is our protection. So we need to go that way, not about UFO, UAP, blah, 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 blue books, blah, blah, blah. No, we need to know who these beings are, and then we need to protect ourselves,
Yes.
our civilization.
Yeah.
can we get back to the point
Yeah,
at hand?
please.
I'm sorry. I sound like a shit, but this is my point.
Yeah, absolutely. We got your point. We will be adaptive in our development. We do not freeze the software and say that's it. It will be adjusted anytime with new material.
Listen, Richard, my point.
Bojan, can I? Yeah, I got your point. Bojan, can we split? Can we stop this, please, now because we want to follow?
Why?
Pardon me? What do you mean with why? We have a topic.
Because
This is a developer meeting, and this is not a philosophical round about UAPs.
no,
Okay?
this is philosophy is the mother of science. So what you're stopping there?
I'm stopping because we have some topics on our list, and when the next topic is climate control, right, Brett?
Sure.
Okay.
Where do we want to start?
Yeah. You are a team leader in the climate control, so Brett, please give us a rundown what happened this week and what the discussions are and the problems are.
So all of us were quite busy. So on my end, mostly printing and testing the hardware setup. I've got one almost completely built, with the exception of the Peltier mounting section, which we're still quibbling over the exact heat sinks and how to mount them and that kind of thing. But once we get that done, I can print those, and then I can send the first one off to George. Let's see what else. I should be done with that if we can get the heat sinks figured out. Probably next week is the earliest I could ship them off or ship that one off.
What is your considerations about heat sinks? Why you say you are not decided yet?
Oh, I haven't figured out the ones I'm going to use, but I think we're all going to kind of choose ones that we like, ones that we can source, and then compare and contrast among ourselves, because it really doesn't make sense for us to all three set up identical things and do trials. I mean, it is costly and inefficient. We can all, repeat the setting, or repeat the experiment ourselves on our own system. There's no need for repeatability among ourselves.
Yeah.
So then it's just a question of, okay, how exactly do we attach the heat sinks to the side of the tube?
Stop right there. So what I learned. So I have this kind of shitty setup, 2 blocks. So what I learned, we have 12 volts power supply, right? Oh, my camera is
We have
crazy.
220 volts power supply, yes, but yeah.
Yeah. So I have I will post. I will hook up my sensor so I to see communication, and what I have so our reference is 12 volts power supply, right?
As an example, you get a 220 volt power supply, and you say what voltage you need.
Then I have I was measuring 11 volts and a constant current 5 amps, 11 volts. So I need to build the constant current circuitry to the handle two connected in a parallel Peltier elements.
Yeah.
So we have what I have delta T is 70 degrees on a 11 volts and 11 volts and a 5 amp 5 amp current.
So 55 watts, and you get out 70 degrees delta T.
So this is just a mathematics. So let's say
Pardon me?
11
What did you say?
by 50. No. 11 by 5, 55 watts. And the thing is, 55 watts, you can translate to joule energy. So
Yes, with a
this is
certain efficiency. Yeah.
this is all we can have. With our power ATS power supply, we can have 70 degrees delta T. This is like a 55 watts. I mean, my
it sounds incredibly much for me.
setup is little stupid, you know. This is little stupid, 2 blocks. But I was thinking about okay, I can measure delta T. Forget about it because these 2 blocks is too close. But the point is. Oh damn! And the point is, we can have max 70 degrees delta T.
Can you tell me your readings on your sensors? What is the hot and the cold side reading for 55 watts?
Richard, tomorrow I will have my current sensors, so I will give you the graph.
Yes, but
And
today you don't
I can,
have, and today you can give me the answer because you already said you have 70 degrees delta T on 55 watts. So my question is, how did you get the 70 degree delta T? You must have known the hot and the cold side temperatures in order to know the delta
you
T.
know, like a stupid design from I'm stupid. You see that? So you see the hot side and a cold hot side and a cold side is too close. So the oh
Yeah,
damn.
this is a different issue. This is a different issue. Boyan, we're
No,
not
no,
talking
no.
about damping now.
Very
I want to
important
know
issue.
how you come up of the delta T 70 degrees. How did you read that?
You know what? My problem is, God damn it. My problem is I put these blocks so close, and these aluminum blocks is uh, the hot side.
How did you read the
Set
70 degrees?
impact. Huh?
How did you read the 70 degrees delta T?
I believe
He had
these
embedded
thermocouples
sensors.
inside it inserted on either
So,
side and milled holes through either heat
yeah,
sink.
yeah.
So you say, George, that he has 2 temperature sensors and he has 70
No, I
degrees difference between these 2 readings.
So
which is right about the delta T max for this particular TC. So I'm not too surprised, being that it's just two solid blocks of aluminum with no airflow over them. It seems pretty likely that the steady state that it would get to would be, the max for the.
yeah, this is my point. This is my point. Okay, I can take a worst case scenario. You know what I'm saying? So this will help us. But anyway, my test setup is so stupid. Right now, I'm more. What I'm trying to do. How can we controlling the constant current through the Peltier elements on a 12 volts, and how much delta T we can have? So please understand me. The problem. Okay. Please understand me. Yeah. Okay. Look, we have 12 volts power supply. Then you need to, in order to keep temperature constant, you need to drive with constant current the Peltier element. In this case, two Peltier element in parallel. On each side on this channel, the Richard and Brad was doing, right?
Yeah.
Yeah. Okay.
Now, I was, the setup is stupid, but this is whatever. The thinking about delta T, I was thinking about how can I drive, because these Peltier elements we buying cheap Peltier elements can go bigger delta T, but like a 17 volts something.
Yeah.
But our is because Brad was saying, hey, look, we're gonna go ATS power supply with 12 volts. So my problem is, so what I have is I set 12 volts maximum on my power supply, bench power supply, and 5 amps. So in this condition, I had 70 degrees delta T. This is all we got. Because this 1 volt between 11 volt and 12 volt, which is our max, I need to have, because the electronic device, whatever, transistor, MOSFET, the chip, you need to put this voltage drop between 12 and 11, 0.7, 1 volt, that's okay. So we are dealing with 11 volts. Guys, you know what I'm talking about?
Yeah. So in some of the early tests I did, I mean, I had a big heat sink and a small heat sink, and I've only put air through the hot side, and I just let the cold side dissipate ambient heat, right? And I was getting delta T's around 40. And
okay.
to optimize that, I mean, I could get the temperature, drive the temperature down a little bit lower if I, cranked it up to 12. I saw my power supply, I set it to a max amp, right? So it won't go past 10. And then I can adjust the current. And either it's going to switch from constant current or constant voltage depending on whichever it hits first, right? So I wouldn't let it exceed 10 amps, or I wouldn't let it exceed voltage. So
Brad,
I could set it to 12, and it would get to this high delta T, so very cold side temperature. And then if I had dialed it back to 9.5 volts, you could actually get the temperature lower.
Brad, you need to take in consideration, in calculation. For example, you have 12 volts power supply, right? This is our reference.
Mm-hmm.
So, and then you drive the Peltier element or elements or whatever with this voltage, but you have device connected in a chain with Peltier elements. So this device, transistor, MOSFET, chip, whatever, has some voltage drop. So is not literally is not ideally is doesn't have any voltage drop, but in a real world, this device has some voltage drop. So I set up 11 volts. So my device, whatever it is, IC, MOSFET, transistor, has voltage drop. So we losing trying to control the constant cooling, the current. We losing 1 volt. Anyhow.
So,
So
what's the relevance now? I don't get it.
it is very important because so I set up my limits. When you're doing electronic design, like any design, you have input. When you're doing the electronic design on any design, you must set up the references, right? So I set up 11 volts and 5 amps, and I have 70 degrees Celsius delta T. This is it.
We heard this already. Okay, so Brad, you said
So we can start from there, unless we put some another power supply. But speaking about price, we can buy cheap ATS power supply. This is it.
So for the we probably should not use ATX power supply for the actual.
Yeah, this is
Bojan, can you please let him talk? Please, Brett, go ahead. To say what you said. Say what you want to say.
It's just that they're so big. I mean, we can just go a small, low-profile one that can fit into the snug.
Okay.
So we don't really need another ATX power.
We want to put it outside of the enclosure so that
it has to be outside the enclosure.
Inside. Yeah, exactly.
Yeah.
So what? Okay. This whole discussion was really confusing for me. First of all, you say with 55 watts we get with 55 watts we get 70 delta T, 70 degrees delta T, right? Is this true, George? Can you confirm such thing? It sounds huge for me.
I can't. I would need to have the data and then compare that with the data sheet.
Mm-hmm.
So and also,
hey, Sinusoid, what is your name? I can call you Sinusoid.
George.
Oh, George.
George, let me tomorrow. I will have the current sensors, and then I will doing the the lab view. Lab view, right?
Yeah.
I'm gonna do some automatic stuff. I'm suffering to not have parts. I mean, this is ordering parts is like waiting 2 weeks, 3 weeks. Okay. So what is my point? Let me do. I will send the graphs and stuff like that. But we need to instead ATS PC power supply. We need to power supply like a 24 volts, even better.
Well, I mean, for the purposes of testing and establishing baselines, we're on the path. We're going to try the cheap Peltiers, which we're going to use 4 of. Those are 12 volts. So that's setting our power supply right now. We may find that this setup is either not efficient, cost-wise, or performance-wise, and we have to step it up to more high-performance Peltiers. That's going to take you to 17 volts, 24 volts, etc., higher amperage. So that would change our power supply, period. So we just have to build this, let it explode, and then rebuild and revise. That's just what we're going to have to do.
You know what, Brad? You guys, you and Richard did a good job about these channels and stuff like that. But my worry is, let's see how much we can have, the delta T, but because delta T is very important.
It is, but I mean, also you have to consider it's about how much heat you're pumping out of the system.
Right.
So having a huge delta T is actually not all that great. I mean, you kind of want to keep the delta T to a narrow range if you can, because the real performance measure here is not necessarily delta T. It's important to consider, but it's how cool can we get the inside of the system, which is going to be a product of how much heat we can pump out of the system.
Plus
the and so right now,
plus the airflow, plus. So
yes. And if we can standardize that, and I actually have 2 light bulbs in mine, we probably all do the same, because a light bulb puts out a standard wattage. If you can find them, I had one 100-watt light bulb, and I think it still works. Just for an hour or wherever, because I mean, Boyan found this out. I have found this out. There is heat contamination if you let it, sit long enough. Heat.
Oh yeah.
Your loop. So we need to standard wattage, let it run for an hour, and just see what we get, and then compare. We can speculate at this point, around, but let's just build it and figure something out.
Even though you have 5 millimeters ABS between the
aluminum blocks,
can be problem. ABS still can be can warming up.
Yeah, Bojan, but your setup is 2 static aluminum blocks. In the real case, there will be heatsinks with fans that blow air so that the heat is dissipating. So there will be less an effect of dissipation from the hot to the cold side through the ABS.
It still is a factor. Remember, I've already built one of these things and it didn't work.
Let me explain you how I doing electronics design, whatever. I'm doing in a worst case scenario.
Yes, but we are planning for a particular purpose, not for a worst case scenario. So the particular purpose is to have a steady airflow in a closed loop system where we exchange air permanently 17 times per minute. And so the effect of heat loss via the ABS is minimal compared to how much dissipation will take place because of the airflow. There will be certainly more energy be dissipated because of the airflow than just because of the 5mm ABS frame. I mean, even if it's there, what else shall we do about it? I mean,
yeah, Richard, you're right, but we also, I mean, and we're going to have to see this. If you have the heat sink and it's getting incredibly hot because it's a hot day and it's dissipating a lot of wattage and it's improperly sized, it can get really, really hot. And the hotter it gets, the greater that temperature differential between the inside of the loop and the outside of the loop, the greater the amount of heat radiation, it's the rate of heat exchange is going to go back. So letting that outside heatsink get too out of control is a problem. So
we already said there it was your point that we have to fan the outside too. So
yes, we have to put a fan on it, but the heatsink has to be able to dissipate enough not to get 60, 80, 100 degrees. Did we sorry, Richard, do you freeze? Hello?
I think he did. I can still hear you.
Okay.
I can hear you too.
I guess
But everyone else was
for a second there.
was freezing, I assume.
Yeah, something wrong.
No, nothing is wrong. I wanted to talk about the last couple of minutes. We are very few minutes now left, before we have to stop. About the test setup. So you're printing now the tube in parts, so that, for example, you can send over to George, that he can set it up. And yes, there are issues with the mounting of the fans and so forth. But this is only for the test setup, yeah.
Yes.
I understood that you want to test several type of heat sinks, so that we not all of us test the same heat sink. So we have maybe the same electronics and we can control the wattage, but we have different heat sinks, so we can test the outcomes, let's say.
Yes.
In that case, if the peltiers will stay the same, I assume, and you only change the heat sinks, the exterior and the interior, so we only have to exchange the holding frame, more or less, nothing else.
Yes.
Okay.
Can I say something?
Go ahead. We are not in school.
No. This is respect.
Okay. Go ahead.
I'm not worried about electronics at all. Period. We can find device, this device, whatever. We can drive this with constant current, no problem. But
we should all use the same electronics. And that's why it's important that you come up with the electronic setup as soon as possible.
I'm not worried about electronics. I worry about the way you guys making this structure so this heat can go out and cooling and heating. I don't know about that. I know about electronics, but
what is your question? What is your question?
I think this. I mean, I don't want to be disrespectful, but current design about this the mechanical the cooling healing.
What is wrong? What is wrong with this, from your point of view? Tell us.
From my point of view, which is I do this stupid my test picture for 2 blocks, 5 millimeters ABS still can go hot, right?
Okay, so let me explain a little bit of physics here. So first of all, you have 2 aluminum blocks, and you put peltiers in between. There is no dissipation because of convection, air, and so forth. It's only thermostatic what you're doing. Okay, you put in power, and the power is transferred into the aluminum. And yes, of course, because your peltier is only 4 millimeters thick, there is heat radiation via the air medium. So yes, you can with the hot side, you heat up the cold side. Yes, this is true. But in our setup, we have heat sinks and fans. And the idea of heat sinks and fans is to dissipate the heat as quickly as possible away from the
Okay.
Peltier. Okay, there should be, if the design of the heat sinks and the fan is correct, there should be almost no heat bead left over on the heat sinks. Okay, there shall be, because yes, of course, but that's the goal, as much as possible to transfer away. You did not transfer away at all. So in your case, your setup has a flaw in a way so that you have really to separate your thermostatic elements. In our case, there is first of all a 5mm ABS. For second, there are little tiny gaps of air in between. And for third, there are heat sinks with fans that are blowing away the heat. Okay, so this is totally different. That's why your concerns cannot, that you rose with your setup, does not apply with the total setup, the climate control setup.
So the concerns of there being too much heat and it transferring through ABS, I mean, that is always a concern. But like this simple setup here, it is just two aluminum heat sinks.
Can you share your screen? Can you?
This is holding it up.
Oh, this is big one. Whoa.
It's just two aluminum heat sinks stuck together. There's no insulating material on the sides, right? So this was enough of a differential to not have an extraordinarily high DT, but I mean, it worked. There wasn't too much heat buildup on the hot side, and there wasn't too much contamination on the cold side. So it's, yeah, you start dissipating some heat away from your system, and you'll see it's not as big as a concern as you think it is.
Yeah.
Still something to consider, though.
You were able to get condensation with that, right? You had quite a bit of condensation buildup.
Yeah.
So I think that's another factor. So immediately when the system kicks on, the first thing that's going to come out is the moisture in the air. So maybe within the control loop, like an outer control loop, how long the system has been running for, don't run it longer than a certain amount of time without giving it time to drain condensate off. If that makes sense. This is kind of thinking further down the road. But
George, how much humidity can impact the cooling system?
Impact the cooling system.
Not sure I understand.
No.
The question.
Okay, you have Peltier element on a cold side and a hot side. So we need to what we need to do to take out the heat side heating the temperature, high temperature from heating side. So how can we do it better, in a better way?
So, if I follow, we can't use, if you're thinking about liquid cooling, we can't use liquid cooling.
Okay, I have this is Jetson. Okay, I'm gonna take heat from here, or we need a fluid.
We can't have fluid.
Why? Sorry, I do not understand the question at all. First of all, there's two ways to cool something. It's water cooling and air cooling. That's what used in computer equipment. But this is not difference to the question that you put to George about humidity in the enclosure. And George was pointing out that when you kick it off, then you have a certain relative humidity already in the air. And so as soon as the climate control starts cooling down, this humidity will condense. Yes, that's true. And this will be especially at the very beginning, because when the relative humidity is still high. Has nothing to do with heat sinks, has nothing to do with fans or a water cooling system. It's only about the dew point that is changing by temperature. And yes, we have to get rid of this humidity. Our idea is not to use it just in a passive way, just to let it drop and sink it out.
And I don't know, maybe I'm missing it, but we do need to keep track of the dew point because when you do change the temperature inside the enclosure, the dew point is something you have to worry about. You can't form condensate on your optics, for instance.
Yeah.
Ideally, it would remove enough of the humidity in the enclosures that it wouldn't be an issue. But I don't know yet. We have to see.
Now, as
But
George
in terms of
as George already said, when you close the system and kick it off, there is a certain humidity inside, and it will drain out over. Yeah, I don't know. We have to find out. Let's say the first hour it will drain out. Let's say just an assumption, but then you will have a certain level of humidity that's always there, that will be not disposable anymore because it is on a grade so that it does not condensate anymore. It's on this, how is this called? It's a super condensation level such name where humidity does
Richard,
not fall out anymore.
Richard, can you give me some range plus minus humidity so we can work on it? I need to some reference, you know.
In percent, in relative percentage of.
Yeah, percentage, yeah.
Stay below
Give me
50% and we are okay.
so plus minus.
Stay below 50% relative humidity and we are mostly okay. Mostly.
So stay below 50.
Yeah. So in common place, let's say for 90% of all cases, this below 50% will be sufficient. But it can be that,
So
yeah.
So from 0 to 50 doesn't matter, or doesn't matter.
No, does not matter. Does not matter. It's only when humidity gets higher that the possibility of condensating on cold plates increases. And this is because we have to keep an inside temperature of between 15 and 25 degrees. When you put it into a cold place, when it's winter, and you have it hot inside, so you have certainly a humidity that can condensate on the outside materials, let's say on the glass sheets of the dome, for example.
So our goal is less than 50. Doesn't matter which one, but less than 50.
In 80% the time, yes.